Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us somewhere both familiar and deeply strange, into the hidden layers of reality itself, into something you may have heard about, perhaps imagined, but never quite touched, the fourth dimension. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a quiet comfort to see how many of us are gathered here, each in our own little corner of time. Now feel free to dim the lights, maybe turn on a fan for a soft, steady hum, and let your body sink gently into wherever you are. And as you begin to relax, I'd like you to hold on to a simple thought: up, down, left, right, forward, back. These directions feel so natural, so complete, as if they fully describe the space around you. Your world feels stable, grounded, understandable. But what if it isn't? What if everything you experience, every direction, every movement, every moment, is only part of a much larger structure, one your mind was never designed to fully see? Tonight, we're not here to rush toward answers. We're here to gently explore a possibility that there may be another direction, not far away, not hidden behind a wall, but woven quietly into reality itself. A direction you cannot turn toward, a dimension you cannot see, and yet one that may already be shaping everything around you. So as your thoughts begin to drift and your breathing slows just a little, let's take a soft step into that unseen space together. If you pause for a moment and notice your body right now, there's a quiet sense of stillness. Perhaps you're lying down or sitting comfortably, feeling the weight of gravity holding you gently in place. The room around you is calm. Nothing seems to be moving, and yet, this stillness is not quite what it seems, because according to everything we understand about the universe, you are not truly at rest. Even now, in this quiet moment, you are moving, not in the way you might expect, not across the room or through the air, but through something far less visible. You're moving through time. It's a strange idea to sit with. Time feels like something that happens to you, like a background rhythm quietly ticking along. Seconds pass, minutes fade, hours drift by, but you rarely think of yourself as travelling through it. And yet, in a deeper sense, that's exactly what you're doing. Imagine for a moment that your life is like a path through a vast landscape, not a path across fields or mountains, but a path that stretches through moments. Each second is like a step forward. You cannot stop taking these steps, you cannot pause between them. You simply continue, steadily, quietly, without ever noticing the motion itself. It's a bit like floating on a slow, gentle river. When the water is calm, you don't feel yourself drifting. There's no wind, no waves, nothing to signal movement. And yet, if you look closely, the shoreline is slowly slipping past. The world is changing around you, even if the motion feels invisible. Time is something like that river. You're always moving along it, carried forward at a steady pace. Even when your body is completely still, even when your thoughts begin to slow and soften, that motion never stops. And here's where things become a little more curious. In the way physicists describe reality, this movement through time is not separate from movement through space. They are part of the same structure, woven together into a single continuous fabric, a kind of four-dimensional landscape where every position is not just where something is, but also when it is. So if someone were to ask, "Where are you right now?" the full answer wouldn't just be your location in the room. It would also include this exact moment, this second, this quiet point in time that will never come again in quite the same way. Without time, your position is incomplete, and that means something subtle but profound. You're not just sitting in space. You're moving through a larger reality that includes both space and time together. Now, there's a gentle way to picture this. Imagine that every person, every object, every tiny particle in the universe is always travelling at a kind of constant pace through this four-dimensional fabric. But that motion can be divided. If you are sitting still, almost all of that motion is flowing into time. You move steadily forward from one moment to the next, aging quietly, second by second. But when you begin to move through space, walking, running, or even orbiting high above the Earth, something shifts ever so slightly. A small portion of that motion is redirected. Instead of moving entirely through time, you begin to move a little more through space, and just a tiny bit less through time. The change is incredibly small at everyday speeds, so small that you would never notice it directly. Your watch still ticks, your thoughts still flow, everything feels the same. But the universe in its quiet precision does notice. Astronauts circling the Earth, for example, are moving faster through space than people on the ground, and because of that they move just a little more slowly through time, not enough to feel, not enough to change their daily experience, but enough that, when measured carefully, it becomes real. They age, just slightly less. It's a delicate shift, almost like a whisper in the structure of reality. But it reveals something extraordinary. Time is not fixed. It is not the same everywhere, for everyone. It is something you move through, and that movement can change. Now, there's no need to hold on to the details too tightly. Let the idea sit lightly in your mind like a thought drifting past. You're always moving, even in stillness, even in quiet. Even now, as your breathing softens and your body relaxes, you're continuing along this invisible path, carried gently from one moment into the next, and perhaps the most curious part of all is that this movement through time may not be the only direction you are travelling. Because if time itself can be thought of as a dimension, a direction you move through without seeing, then maybe, just maybe, there are other directions as well. Directions that do not feel like up or down. Directions your body cannot turn toward. Directions that are there, quietly shaping reality, without ever appearing in your senses. And to begin understanding those hidden directions, we first have to take a step back and ask something deceptively simple. What is a dimension, really? There is something quietly comforting about a map. A map gives you a sense of certainty. It tells you where you are, where you're going, and how to get there. It takes the vast, complicated world and folds it neatly into something you can hold in your hands or glance at on a screen. And for the most part, it works beautifully. You can travel across cities, cross countries, even navigate oceans, all guided by these simple representations of reality. But here's something we don't often stop to think about. Every map you have ever used is wrong, not useless, not misleading in a practical sense, but fundamentally, mathematically, wrong. And the reason is surprisingly simple. The Earth is not flat. It's a curved surface, a sphere. And whenever you try to flatten something curved onto a flat surface, something has to give. Imagine peeling an orange. As long as the peel wraps around the fruit, everything fits perfectly. But the moment you try to press that peel flat onto a table, it begins to stretch, tear, and distort. Some parts widen, others shrink, shapes warp, distances shift. There is no way to flatten it perfectly. Every flat map of the Earth is doing exactly this, taking a curved reality and forcing it into a simpler form. Some maps stretch the poles, making Greenland look enormous, Others compress distances near the equator. Some preserve shape but distort size. Others preserve distance but distort direction. Each map chooses what to keep and what to sacrifice. And yet, we rely on them every day without question, because they are good enough. They don't need to be perfect, they just need to be useful. Now, let that idea settle for a moment, because something very similar may be happening inside your own mind. Your brain is constantly building a map of reality, not a literal one with roads and borders, but a model, a simplified version of the world that helps you survive, navigate, and make sense of your surroundings. It tells you where things are, how far away they seem, how fast they're moving, what matters and what doesn't. But just like a map, it is not the full truth. It cannot be. The real world is far too rich, far too complex, far too detailed for your brain to capture completely. So instead, your mind filters it. It selects certain information, ignores the rest, and presents you with a version of reality that is manageable, stable, coherent, familiar, but not complete. For example, the light your eyes can detect is only a tiny slice of what actually exists. There are wavelengths beyond what you can see, ultraviolet, infrared, and more, passing through your environment constantly, unnoticed. There are sounds too high or too low for your ears to register, vibrations, signals, patterns, all present but invisible to your senses. Even time itself, as we've begun to explore, is not experienced directly. You don't feel its structure, you don't sense its curvature or its variability. You simply experience a steady flow one moment after another, a simplified version, a map. And just like with geographic maps, this internal model works well enough for everyday life. You can walk, talk, recognize faces, avoid danger, find your way home. But that doesn't mean you are seeing everything. It only means you are seeing what you need. Now here's where things begin to shift, very gently. If your brain is already simplifying a three-dimensional world into something manageable, what happens if reality itself has more dimensions than you can perceive? What happens if there are aspects of the universe that cannot be flattened into your mental map without distortion? It would mean that your understanding of reality, no matter how confident it feels, is only an approximation. A useful one, yes, but still incomplete. There's a quiet analogy that helps bring this into focus. Imagine for a moment a world that exists entirely on a flat sheet of paper. The inhabitants of this world can only move left, right, forward, and backward. They have no concept of up or down, because those directions simply do not exist in their experience. Now suppose they create maps of their world. From their perspective, these maps would seem perfect. Every location, every path, every distance, accurately represented within the limits of their two-dimensional understanding. But we, standing outside that world, would immediately notice something they cannot. Their entire reality is missing a direction, not because it isn't there, but because they cannot perceive it. To them, their map is complete. To us, it is only a slice. And in a quiet, almost humbling way, we may be in a similar position. Our understanding of space, forward, backward, left, right, up, down, feels complete. It feels like the full set of possibilities. But that feeling may be deceptive, because just as a flat map cannot perfectly represent a curved Earth, our three-dimensional perception may not perfectly represent the deeper structure of reality. There may be directions that are not just far away, not just hidden behind something, but fundamentally inaccessible to our senses. Directions that cannot be drawn, cannot be pointed to, cannot be turned toward, and yet they may still exist. This idea can feel a little unsettling at first. It gently challenges the trust we place in our own perception. It suggests that what feels solid and complete might actually be a simplified projection of something far more intricate. But there is also something quietly beautiful about it, because it means that reality is not smaller than we imagined. It is larger, richer, more layered, and science, in its careful and patient way, is not trying to replace our map, but to refine it, to extend it, to reveal where it bends, where it stretches, and where it begins to fall short, just as explorers once realized that the Earth was not flat but curved. We are beginning to realize that space itself may not be limited to what we can directly perceive, and that realization leads us gently to a deeper question. If our current map of reality is incomplete, if there are directions we cannot see, then what exactly is a dimension in the first place? Not as a complex mathematical idea, but in the simplest, most intuitive sense. Because once we understand that, we begin to see how a fourth dimension might not be something mystical or distant, but simply another direction. If you've ever watched sunlight pass through a window at just the right angle, you might have noticed how it changes depending on what stands in its way. A thin curtain softens it into a gentle glow. A piece of coloured glass turns it warm or cool. Even dust in the air can make the light visible, revealing tiny particles drifting slowly in the stillness. The light itself hasn't changed, only the way it is, filtered, and in a quiet, almost invisible way. Something similar is happening every moment inside your own mind, because what you experience as reality is not the raw, unfiltered world. It is a carefully constructed version of it, a translation, a model, a filter. Your brain is constantly receiving an overwhelming stream of information: light, sound, pressure, temperature, motion. Signals arrive from your eyes, your ears, your skin, your internal senses. Each one carries fragments of the world outside, but instead of showing you everything, your brain selects, simplifies, and organizes these signals into something manageable, something meaningful, something that helps you survive, and in doing so, it leaves things out. For example, the light you see, colours like red, blue, green, is only a tiny slice of what actually exists. Beyond what your eyes can detect, there are other forms of light stretching outward in both directions. Some carry more energy, some less, but all of them pass through the world just as naturally as the light you can see. They are present, but invisible. Your ears behave in a similar way. There are vibrations all around you right now, some too deep, some too high for you to hear. Entire layers of sound exist beyond your perception, moving quietly through the same space you occupy. Even something as familiar as temperature is not directly felt in the way we might imagine. Your body detects changes, differences, patterns, and then interprets them into sensations like warmth or cold. What you experience is not the raw signal, it is the brain's interpretation. And perhaps the most interesting part of all is this: your brain is not trying to show you the truth, it is trying to show you what is useful. From an evolutionary perspective, accuracy is not the goal, survival is. If detecting a certain pattern helps you avoid danger, find food, or navigate your environment, your brain will prioritize that information. If something has no immediate relevance to your survival, it may simply be ignored, even if it is physically present. In that sense, your perception is not a window. It is more like a dashboard, a simplified interface that highlights what matters and quietly hides everything else. There's a gentle way to imagine this. Picture yourself wearing a pair of glasses that filter out most of the world, leaving only what you need to function. You might see outlines instead of details, movement instead of colour, patterns instead of textures. At first it might feel limiting, but over time it becomes normal, comfortable. You begin to trust it completely, and that's where the subtle illusion forms. Because once something feels normal, it begins to feel complete. You stop questioning what might be missing. Now, consider this. There are creatures on this planet that experience the world very differently from you. Some birds can sense the Earth's magnetic field, navigating vast distances using a kind of internal compass. To them, direction is not just something they see, it is something they feel. Certain insects detect heat patterns with remarkable precision, allowing them to locate living bodies even in darkness. Their version of reality includes details you cannot access. Other animals can see beyond the colours visible to humans, perceiving patterns on flowers or surfaces that remain entirely hidden to your eyes. Each of these creatures lives in the same physical world, and yet they experience entirely different versions of it, different maps, different filters, and none of them are seeing the whole picture. Which leads to a quiet, almost humbling realization. If your senses are limited, if your brain filters reality for usefulness, if entire layers of existence can remain invisible, then it is entirely possible that something as fundamental as a fourth dimension could exist. Not as something far away, but as something present and simply unnoticed. Not because it isn't there, but because your mind was never designed to perceive it. There is a kind of stillness in that thought. It doesn't need to feel overwhelming. It can simply sit beside you like a quiet possibility. Because history has shown us again and again that our understanding of the world expands over time. There was a time when people believed the Earth was flat, because that's what their perception suggested. There was a time when the smallest building blocks of matter seemed indivisible, because nothing smaller could be observed, and each time reality turned out to be deeper than it first appeared. Not wrong, just incomplete. So perhaps the same is true here. Perhaps what you experience as a complete picture of space is only a partial view, a version shaped by biology, a model refined by survival. And just beyond that model, just outside the limits of perception, there may be more, not something mystical, not something unreachable, just something unobserved. And that brings us gently to the next step. If our senses cannot reveal the full structure of reality, then we need another way to understand it, a simpler way, a more fundamental way, something we can build from the ground up, so we can begin to ask, in the most basic sense, what is a dimension really? Not as a complex idea, not as an abstract formula, but as something you can almost feel, as a way of moving, of changing, of existing. Because once that becomes clear, the idea of a fourth dimension begins to feel just a little less distant and a little more real. Let's begin with something very simple, not complicated, not abstract, just something you already understand. Without needing to think about it, imagine standing on a straight line. There is only one way to move. You can go forward or backward. That's it. No turning, no stepping sideways, no moving around, just one path stretching in two directions. Yes, that world, everything exists along that single line. Your entire reality would be defined by just one dimension. Now, gently expand that idea. Instead of a line, imagine standing on a flat surface, a sheet of paper stretching out in all directions. Suddenly, you have more freedom. You can still move forward and backward, but now you can also move left and right. Two independent directions. Two ways to move that are completely separate from one another. This is what we call two dimensions, and if you pause for a moment, you can almost feel the difference. A line feels restrictive, a plane feels open. There is more possibility, more room to explore. Now, take one more step. Imagine lifting yourself off that flat surface, into space. Now you can move forward and backward, left and right, and also up and down. You're no longer confined to a surface. You can rise above it, move beneath it, explore around it. 3 independent directions, 3 dimensions. This is the world you are familiar with, the one your body understands naturally without effort. You don't have to think about how to move in 3 dimensions, you simply do. You reach for objects, walk through rooms, turn your head, adjust your position, all within this 3-dimensional space that feels complete and self-contained. And because it feels complete, it's easy to assume that it is. But here's the quiet shift. What if completeness is just a feeling? What if the sense that this is everything comes not from reality itself, but from the limits of your perception? Because when mathematicians and physicists talk about a 4th dimension, they're not talking about something vague or mystical. They're describing something very specific. Another direction. Not a direction you can see, not one you can point toward, not something that lies far away in space, but a direction that is completely independent from all the ones you already know. Not forward, not backward, not left or right, not up or down, something else. And this is where the mind begins to hesitate, because every direction you've ever experienced can be described using just 3 measurements: length, width, and height. Your entire intuition is built around these 3 ways of moving. So when you try to imagine a 4th, there is nothing to hold on to. It doesn't turn into a picture. It doesn't become a shape. It simply slips away. There's a gentle way to understand why. Imagine trying to explain up to a being that lives entirely on a flat surface, a 2-dimensional creature. From your perspective, up is obvious. You can rise above the surface, lift objects, move freely in that direction. But to them, there is no such thing. Every direction they know lies within their flat world. If you tried to explain up, what would you say? You couldn't point to it. You couldn't draw it. Any attempt to describe it would end up sounding abstract, or even impossible, and yet, from your perspective, it is perfectly real. Now gently turn that idea toward yourself. Just as a 2-dimensional being cannot imagine up, you may not be able to imagine the 4th dimension, not because it doesn't exist, but because your brain was never built to visualize it. Your intuition has a ceiling, and that ceiling is shaped by the world your ancestors needed to survive in, a world that only required 3 dimensions of space. So when you try to go beyond that, your imagination reaches its edge. It begins to recycle familiar ideas. It stretches existing directions, twists them, overlaps them, but it never truly creates something new, because it can't. And that's okay, because understanding doesn't always require visualization. Sometimes it begins with something much softer, a pattern, a progression. Notice how each step we've taken adds a new way to move. From 1 dimension to 2, a new direction appears. From 2 to 3, another direction opens up. Each time the world becomes richer, more complex, more flexible. So if that pattern continues, then moving from 3 dimensions to 4 would simply mean adding 1 more independent direction. A direction that is not a combination of the others, not diagonal, not distant, not hidden behind something, but entirely new. And while you may not be able to picture it, you can still understand the logic. You can still follow the pattern, and that's where the idea begins to settle, quietly. The 4th dimension doesn't need to look like anything familiar. It doesn't need to form an image in your mind. It only needs to exist as a possibility, a natural extension of the structure we've already seen. There is a kind of calm in accepting that. You don't have to force your mind to see it. You can simply allow the idea to be there, just beyond the edge of imagination, like a direction you cannot turn toward, but that still shapes the space around you. And as this thought lingers gently in your mind, there's a natural curiosity that begins to unfold. If a new dimension is just a new direction, then what would a world look like if someone lived in fewer dimensions? What would they see? What would they miss? And more importantly, what would we be missing right now? There is a quiet story that has been told for well over a century now. A strange, simple story about a world that is completely flat. Not metaphorically flat, but truly flat, like a sheet of paper stretching endlessly in all directions. In that world live beings who have never known height. They move forward and backward, left and right, but there is no above and no below. Those ideas simply do not exist for them. Their entire reality is confined to a surface. This story comes from a small but remarkable book called Flatland, and while it may seem whimsical at first, it quietly holds one of the most powerful ways to understand higher dimensions. In this world, the inhabitants are shapes, triangles, squares, circles, each one living out their lives on this endless plane. They see one another not as full shapes, but as lines, thin slices of each other, because that is all their world allows them to perceive. A square, for example, does not appear as a square, it appears as a line that changes length depending on how it is oriented. Everything they know is based on these limited observations, their laws, their society, their understanding of reality, all built from what they can see and measure within their two-dimensional existence. And for them, it feels complete. It feels like everything there is. Now, imagine something extraordinary happens. A three-dimensional object, a sphere, passes through their world. To us, this is simple, a sphere moving through a flat plane. But to a being in Flatland, the experience would be deeply confusing. At first, a tiny point appears out of nowhere. Then it expands into a small line, growing wider and wider. The line reaches a maximum size, then begins to shrink, slowly at first, then more quickly, until it disappears entirely. From their perspective, something has appeared, changed shape, and vanished without explanation. No door opened, no boundary was crossed, no cause can be found within their understanding of reality. To them, it would feel like magic, or something even more unsettling, something that breaks the rules of their universe. But from our perspective, nothing mysterious has happened. We understand that what they saw was only a cross-section, a slice, of a three-dimensional object passing through their world. They never saw the sphere itself. They only saw the parts of it that intersected with their plane. And this is where the idea becomes quietly profound. Because in a gentle, almost humbling way, we may be in the same position. Just as the beings in Flatland cannot perceive the full structure of a three-dimensional object, we may not be able to perceive the full structure of a four-dimensional one. If a higher dimensional object were to pass through our world, we wouldn't see it in its entirety. We would only see its intersection with our three-dimensional space, a kind of slice, a partial view, something that appears, changes and disappears in ways that feel impossible, only because we cannot see the full picture. There's a soft way to imagine this. Picture a three-dimensional object casting a shadow onto a flat surface. The shadow is real. It has shape, size, movement, but it is not the object itself. It is a projection, a reduced version of something more complex. Now extend that idea one step further. If a four-dimensional object were to interact with our world, what we perceive might be something like a shadow of that object, not in the sense of light and darkness, but as a lower dimensional projection of something higher. And just like a shadow, it could behave in ways that feel unusual. It might stretch, twist, or change form in ways that don't seem to follow the rules we expect, not because the rules are broken, but because we're only seeing part of the structure. There is also something else, something even more subtle, hidden within this idea. The beings of Flatland do not just fail to see the third dimension, they cannot even imagine it properly. If you tried to explain it to them, you would struggle. You might describe it as a direction that is not along the plane, but those words would not carry meaning for them. Their minds would try to translate your explanation into something familiar. They might think you are describing a very small direction within their plane, or a very distant one, or something abstract and undefined. But they would never truly grasp it, because their entire way of thinking is shaped by the dimensions they experience. And again, gently, we may be the same. When we try to imagine a fourth dimension, our minds attempt to reshape it into something we already understand. We twist space, we stretch shapes, we picture impossible rotations, but we're still thinking within the limits of 3 dimensions. We are like Flatlanders trying to imagine up, and yet, despite that limitation, something remarkable happens. We can still understand the idea logically. We can follow the pattern. We can recognize that just as a third dimension exists beyond the second, a fourth may exist beyond the third. We don't need to see it fully to begin exploring it. There is a quiet beauty in that, because it means that our understanding of reality does not end where our senses do. It can extend further, guided by reasoning, by patterns, by careful thought. And perhaps that is what makes us different from the beings of Flatland. Not that we can see more, but that we can imagine beyond what we see. We can ask questions about dimensions we cannot perceive. We can build ideas, test them, refine them. We can slowly, gently expand our map of reality, even if we never experience it directly. So as you sit here, resting in your familiar 3-dimensional world, there's a soft possibility to hold on to, that what you see around you, this room, this space, this quiet moment, may only be a slice, a thin layer of a much richer structure, and just beyond it, in a direction you cannot turn toward, there may be more. And to begin approaching that unseen structure, there is a simple path forward, not by trying to see it directly, but by building it, step by step, from the simplest shapes we know into something that gently reaches beyond them. There is something quietly fascinating about shadows. They follow you everywhere, stretching and shrinking depending on the angle of light, sometimes sharp and clear, sometimes soft and barely there. Most of the time, we don't pay much attention to them. They feel like simple byproducts of light and shape, but if you pause for a moment and really look at a shadow, you begin to notice something unusual. A shadow is real. You can see it. You can point to it. It has shape, movement, boundaries, and yet it is not the object itself. It is a reduced version of something more complex. Imagine holding a simple object in your hand, perhaps a cube. In 3 dimensions, the cube has depth. It has faces you cannot see all at once. It exists fully in space. But when light shines on it and casts a shadow onto a flat surface, that shadow becomes 2-dimensional. All of the cube's depth is compressed. All of its hidden sides disappear. What remains is only a projection, a simplified version of the original shape. From the shadow alone, you might guess what the object is, but you would never have the full picture. And yet, if you had never seen a 3-dimensional object before, if your entire world was flat like a sheet of paper, that shadow might feel complete. It might feel like the object itself. Now gently extend that idea. Just as a 3-dimensional object can cast a 2-dimensional shadow, A 4-dimensional object could cast a 3-dimensional shadow, and that shadow could be what we experience as reality. It's a subtle shift in perspective. Instead of imagining the 4th dimension as something far away, something distant or separate, you begin to consider that what you see around you might already be connected to it, not directly, but as a projection, a slice, a shadow of something larger. There is a quiet analogy that can help this settle in. Imagine you're watching the shadow of a hand on a wall. The fingers stretch and bend. The shape changes as the hand moves. At times, the shadow looks almost like a creature of its own, alive, dynamic, expressive. But no matter how complex the shadow appears, it is always tied to something beyond the wall, something you cannot see directly from that flat surface. Now imagine that you are not standing in the room, but instead living on the wall itself. The shadow would be all you know. You would study it, describe it, perhaps even build rules around how it behaves. But the true cause, the hand moving in 3-dimensional space, would remain hidden. And in a quiet, thought-provoking way, this might reflect our own situation. Because if a 4th dimension exists, then what we perceive as solid objects, as movement, as change, might be influenced by structures we cannot directly observe. We would be seeing only the shadow of those higher dimensional interactions. This idea may sound abstract at first, but it begins to feel more natural when you return to the story of Flatland. The square in that flat world did not see the sphere. He saw a circle that appeared, expanded, and vanished. What he experienced was not the object itself, but its intersection with his world, a slice. And that slice behaved in ways that seemed impossible, only because the full structure remained hidden. Now imagine something similar happening in our world. If a 4-dimensional object were to pass through our space, we might see something appear suddenly, change shape in unusual ways, and then disappear without leaving a trace. From our perspective, it might feel like an illusion, or something unexplainable, but from a higher dimensional perspective, it would be perfectly ordinary, just geometry, just structure. There is also something quietly elegant about how this connects to time, because time, as we've begun to explore, can be thought of as a dimension, one that we move through continuously. And if that's the case, then what we experience as a sequence of moments might actually be a series of slices through a larger structure, like flipping through pages of a book. Each page shows a slightly different scene. On its own, each one feels complete. But together, they form a continuous story. You don't see the entire book at once, you experience it one page at a time, and in a similar way, you may be experiencing reality as a sequence of slices, moving through a deeper 4-dimensional structure that remains just out of view. There's no need to force this idea into a clear picture. It doesn't need to be fully visualized. It can simply exist as a quiet possibility, that what you see, what you touch, what you experience as solid and real, may not be the whole object, but rather a projection, a shadow, a cross-section of something more complete. And this doesn't make reality less real. If anything, it makes it richer, because it suggests that behind the familiar shapes and movements of your everyday world, there may be deeper layers, gently influencing everything you observe. Layers that don't contradict what you see, but extend beyond it. And as this idea settles softly in your mind, there is a natural next step. If what we experience may be a projection of something higher, then perhaps we can begin to understand that higher structure, not by seeing it directly, but by building it piece by piece, starting from the simplest possible form, and gently extending it into something that reaches just beyond our 3-dimensional intuition. Let's begin, once again, with something very small. So small that it almost feels like nothing at all. A single point, no length, no width, no height, just a location, a position that exists quietly without taking up any space. It's difficult to picture because the moment you try to imagine a point, your mind gives it size, a tiny dot, a speck, something you can see. But in its purest sense, a point has no size at all, it simply is. Now, gently, let that point begin to move. As it moves, it traces out a path, and that path becomes something new, a line. A line has length. It stretches from one place to another. You can move along it, forward and backward, but nowhere else. This is our first step into structure, from something dimensionless into something with one dimension. Now take that line and extend it in a direction it has never gone before, not along itself, but sideways into a new direction. As it moves, it sweeps out a surface, and that surface becomes a square. Now we have two dimensions, length and width. You can move across this square in ways that were not possible on the line. There is more freedom, more possibility. Already the world feels richer. Now let's continue. Take that square and lift it into a new direction. Not along its surface, but upward, into a direction completely independent from the first two. As it moves, it forms a shape with volume, a cube. Now we're in 3 dimensions, length, width, height. The world we are familiar with, the one your body understands without effort. You can walk around a cube, look at it from different angles, hold it in your hands. It feels complete, solid, real, and yet the pattern is still unfolding. Because each time we have done the same thing. We started with a shape and extended it into a new direction, a direction that did not exist within the shape before. So, very gently, we ask the question again, what happens if we take this cube and extend it into yet another new direction? Not up, not sideways, not forward or backward, but into a direction that is entirely separate from all 3. This is where our intuition begins to fade, because we cannot point to this direction. We cannot visualize it in the same way. Our minds reach for familiar axes, left, right, up, down, but none of them apply. And yet, the logic remains. If a line extended sideways becomes a square, and a square extended upward becomes a cube, then a cube extended into a new 4th direction would become something else, a 4-dimensional shape. This shape has a name. It is called a tesseract. You can think of it as the 4-dimensional version of a cube, just as a cube is the 3-dimensional version of a square. Now there's no need to force a clear image of it. Instead, let's approach it gently, through relationships. A square is made of 4 edges, a cube is made of 6 square faces, and a tesseract is made of 8 cubes, not stacked in a way you can see, but connected through that 4th direction. There's a quiet symmetry here. Each step adds not just a new direction, but a new layer of structure. A line has endpoints, a square has edges, a cube has faces, and a tesseract has volumes. Each dimension builds upon the last, extending reality into something more complex and more difficult to visualize. Now, you may have seen images of something called a tesseract before. Often it appears as a smaller cube nested inside a larger cube, with lines connecting their corners. Sometimes it rotates in a way that feels slightly unsettling, as if it's folding into itself. That image is not the tesseract itself, it is a projection, kind of shadow, of a 4-dimensional object cast into 3 dimensions. Just like a cube can cast a square shadow onto a flat surface, a tesseract can cast a cube-like shadow into our space, and because of that, it behaves in ways that feel unusual. Edges seem to pass through one another, shapes appear to invert or unfold. This structure doesn't sit still in the way we expect, But this is not because the shape is impossible. It is because we are seeing it from a limited perspective. There is a soft way to sit with this. You don't need to see the tesseract fully. You only need to understand the pattern that leads to it. Each dimension is simply a new way to move, a new direction that expands what is possible. And the fourth dimension is just the next step in that pattern. It doesn't need to be mystical. It doesn't need to be imagined perfectly. It only needs to be accepted as a continuation. There is something calming about that, because it removes the pressure to visualize something beyond your reach. You can simply follow the logic, step by step, letting the idea form gently without forcing it into a picture. And as you do, something interesting begins to happen. The fourth dimension starts to feel less like an abstract concept and more like a natural extension of reality. Not something separate, but something quietly connected to everything you already know. And if a tesseract is the four-dimensional version of a cube, then what we see of it, if we ever could, would not be the full object, only a projection, only a shadow, something that moves and shifts in ways that feel unfamiliar because we are only seeing part of the whole. And that brings us very softly to the next thought. If we can only see a shadow of a four-dimensional shape, then what we experience as reality may also be shaped by something just beyond our perception, something that does not sit still, something that cannot be fully captured in 3 dimensions, a shape that refuses to stay within the limits of our understanding. If you've ever watched one of those looping animations online, the kind where a strange wireframe cube seems to rotate and fold into itself, you may have felt a quiet sense of confusion, not the sharp kind that demands an answer, but a softer kind. The kind where your eyes try to follow the motion and your mind almost understands, but not quite. Edges pass through one another, corners seem to turn inside out, the shape expands and contracts in a way that feels just slightly off. And yet, there is a rhythm to it, a structure. It doesn't feel random, it feels like something real, just beyond your grasp. What you're seeing in those moments is not a four-dimensional object itself, it is a projection, a three-dimensional shadow of something that exists in a higher dimension. And just like the shadow of a cube on a flat surface can only capture part of its structure, this projection can only capture part of the tesseract. There is a gentle way to understand why this looks so strange. Imagine, once again, that you are a being living in a flat two-dimensional world. A cube, a three-dimensional object, passes above your world, casting a shadow onto your plane. As the cube moves and rotates, its shadow changes. At one moment it might look like a square. At another, it stretches into a shape that no longer resembles anything familiar. Edges seem to shift. Angles distort. The shape becomes something difficult to name. From your perspective, the shadow behaves in ways that feel confusing. But from a higher perspective, it makes perfect sense. Because the cube itself is stable. It is your limited viewpoint that creates the illusion of distortion. Now, gently bring that idea back into your own world. When you look at a rotating tesseract projection, you are in the position of that two-dimensional observer. You are watching the shadow of a higher dimensional shape. And as it moves through that unseen fourth direction, the projection changes in ways that your brain struggles to interpret. It's not that the object is unstable, it's that you are only seeing part of it. There is something quietly reassuring about that, because it means the confusion you feel is not a failure to understand. It is a natural response to limited information. Your mind is doing exactly what it should, trying to make sense of something that extends beyond its usual boundaries, and so it reaches for familiar patterns. It tries to interpret the projection as a three-dimensional object, It looks for consistent edges, stable faces, recognizable shapes. But the projection does not behave like a normal object, because it is not one. It is the intersection between something higher and your limited perspective. There's a soft analogy that can help this settle more comfortably. Imagine trying to understand a person by looking only at their shadow. You might see their outline, their movement, the way they gesture or shift their weight, but you would miss so much: their depth, their expression, the details that give them full form, and sometimes, depending on the angle of the light, their shadow might stretch or distort in ways that don't match their true shape at all. The shadow is not wrong. It is simply incomplete. And this is how the tesseract appears to us, not as it truly is, but as a kind of shadow cast into our three-dimensional world. There's another gentle way to think about it. When a cube rotates in 3 dimensions, you can follow its motion easily. You can see how each face moves, how each edge shifts, but if a tesseract rotates through the 4th dimension, part of that motion happens in a direction you cannot perceive, so what you see is only the portion of the motion that intersects with your space. It's like watching a dance where half the movement is hidden. You can see enough to know something is happening, but not enough to fully understand it. And so the shape appears to twist, to invert, to pass through itself, not because it is breaking the rules, but because it is following rules you cannot fully see. There is something quietly beautiful about that idea, because it suggests that reality itself may contain layers of structure that are perfectly consistent, even if they appear confusing from our limited viewpoint. It reminds us that what feels strange or impossible may simply be incomplete understanding, and as you sit with that thought, there is a gentle shift that begins to take place. Instead of trying to force the tesseract into something familiar, you allow it to remain unfamiliar. You let it exist as something just beyond your full perception, something you can approach but not completely capture. And in doing so, the discomfort fades. What remains is curiosity, a calm awareness that there is more to reality than what can be easily seen, and perhaps a quiet sense of wonder. Because if even a simple geometric shape can extend beyond our ability to fully perceive it, then what else might be structured in ways we cannot directly observe? What other aspects of reality might be quietly unfolding in directions we cannot turn toward? And what would it feel like not to see those higher dimensions, but to experience their effects, not as diagrams or projections, but as events, as moments that appear, change, and disappear, in ways that feel almost impossible? Imagine your room exactly as it is right now. The walls are still. The air is quiet. Every object sits where you expect it to be. There is a comforting sense of order, a feeling that everything is contained, predictable, and understood. Now, without any warning, something appears, not through the door, not through a window, not from behind you or above you. It simply appears. At first, it might look like a small shape, suspended in the air. Something unfamiliar but not immediately alarming. Then slowly it begins to change. It grows, it stretches, its form shifts in ways that feel almost organic, yet not quite alive. Edges seem to pass through one another. Surfaces appear, then vanish, then reappear in different orientations, and just as quietly as it arrived, it disappears. No sound, no trace, no explanation. The room returns to stillness, as if nothing had happened. If you were to experience something like this, your mind would begin searching for explanations. Perhaps it was a trick of the light, a momentary lapse in perception, something you imagined, because within the framework of your everyday understanding, there is no place for something like that. And yet, there may be another way to interpret it, a quieter, more geometric way. Instead of thinking of this as something impossible, imagine that what you witnessed was only a small part of a larger structure. A structure that exists in more dimensions than you can perceive, just as the square in Flatland saw only a circle when a sphere passed through its world. You may have seen only a slice of a higher dimensional object moving through your space, not the object itself, just its intersection with your three-dimensional world. There is a gentle way to visualize this. Picture a sphere passing through a flat surface. At first, only a single point touches the surface. Then, as the sphere moves further through, that point becomes a small circle. The circle grows larger, reaches a maximum size, and then begins to shrink until it disappears entirely. From the perspective of the flat world, something has appeared, changed shape, and vanished. But from our perspective, nothing mysterious has occurred. The sphere remained whole the entire time. Only the portion intersecting the flat surface was visible. Now, bring that idea one step higher. If a four-dimensional object were to pass through our space, we would not see it in full. We would see only the parts that intersect with our three-dimensional world. And those parts might change in ways that feel unfamiliar, because the object itself is moving through a direction we cannot perceive. There is something quietly fascinating about this, because it means that what appears to be transformation may simply be motion. What looks like distortion may be structure. What feels like something appearing out of nowhere may just be something entering our slice of reality from a direction we cannot see. There is also something a little humbling about it, because it suggests that our understanding of inside and outside, of here and there, may not be as absolute as it feels. In our world, objects are contained by boundaries. A box holds what is inside it. A room encloses its contents. A wall separates one space from another. But these ideas depend on the dimensions we can access. If there were an additional direction, one that we cannot move through or perceive, then those boundaries might not be complete. There could be paths that bypass them entirely, not by breaking through, but by going around in a way we cannot follow. There is a soft analogy that helps this settle. Imagine again a two-dimensional world like Flatland. A square builds a perfectly sealed vault. The walls are solid lines with no gaps or openings. From within that world, it is completely secure. Now you, existing in 3 dimensions, approach this vault. You do not need to break the walls. You do not need to open a door. You simply reach down from above, lift the object out, and leave. From the square's perspective, the object has vanished. No boundary was crossed. No rule was broken. And yet, the vault was not secure after all. Now, gently turn that idea back toward your own world. If a 4th spatial direction exists, then a being that can move through it would not be limited by the boundaries you perceive. A sealed room would not be fully sealed. An enclosed object would not be fully enclosed. Access would not require breaking through, only moving in a direction you cannot access. There is something both unsettling and quietly elegant about that, because it reframes what we think of as solid and impenetrable, not as absolute barriers, but as limitations of perspective. And yet, this idea does not have to feel threatening. It can also be seen as an expansion, a reminder that the rules we observe are not broken. They are simply part of a larger system, a system that extends beyond what we can directly perceive. And if such higher dimensional interactions were possible, they would not feel like complex operations to those performing them. They would feel simple, natural as reaching out your hand or stepping forward. Which brings us to a gentle realization. What we experience as reality, with all its structure, its boundaries, its consistency, may only be one layer of a much richer framework, a layer shaped by the dimensions we can access, and defined by the directions we can move through. And just beyond that layer, there may be others, not chaotic, not random, but structured in ways that simply extend beyond our current understanding. So if something were to appear in your room, change form, and vanish without a trace, it might not be magic, it might not be an illusion, it might simply be a glimpse, a brief intersection between your world and something just beyond it. And as that idea settles quietly in your mind, there is a natural curiosity that follows. If higher dimensions allow access beyond boundaries, then what would happen if something truly valuable, something carefully protected, was placed inside a space we believe to be completely secure? Would it really be safe, or would it only seem that way from our limited perspective? Let's return gently to something familiar, a room, a space with walls, a door, perhaps a window. Inside, something valuable is kept safe. Maybe it's an object, something rare and irreplaceable, something you would never want to lose, so you secure it. The walls are reinforced, the door is sealed, sensors are installed, every possible entry point is accounted for from every angle you can perceive. The room is completely closed, nothing can get in, nothing can get out. There is a quiet sense of certainty in that, a feeling that the space is protected, contained, under control. Now imagine stepping outside for just a moment, and when you return, the object is gone. Not broken, not damaged, not moved, gone. The walls remain intact. The door is still sealed. The sensors show no disturbance. There's no sign of entry, no trace of intrusion. Everything looks exactly as it did before, except for the absence. At first, your mind searches for explanations, a malfunction, a hidden passage, a mistake in the system. Because within the rules of your world, something cannot simply vanish from a sealed room. And yet, what if the room was never truly sealed? Not in the full sense, only sealed within the dimensions you can perceive. There is a quiet way to understand this. Return once again to Flatland. Imagine a two-dimensional creature, a square, who builds a perfect vault. From its perspective, the vault is completely secure. The walls are solid lines, forming a closed boundary with no openings. Inside, it places something valuable. Now you, a three-dimensional being, approach this vault. You do not need to break the walls. You do not need to open a door. You simply reach down from above into a direction the square cannot perceive and lift the object out. To the square, the object disappears. No boundary was crossed. No rule was broken. And yet, the vault failed. Not because it was poorly built, but because it was incomplete. It did not account for a direction beyond its understanding. Now gently bring that idea back into your own world. If there exists a fourth spatial direction, one that lies beyond forward, backward, left, right, up, and down, then any space you create, any enclosure you design, is only sealed within 3 dimensions. There may still be a way in, not through the walls, but around them, through a direction you cannot access. There is something quietly unsettling about that idea, because it suggests that what we consider secure, what we consider contained, may only be secure relative to our limited perspective. But there is also something deeply fascinating, because it reveals how boundaries themselves are not absolute. They are defined by the dimensions we inhabit. Expand those dimensions, and the boundaries change. There is another gentle example that makes this idea feel more tangible. Think about your own body. From your perspective, your skin forms a boundary. It separates your internal organs from the outside world. It defines what is inside, and what is outside. And within the rules of three-dimensional space, accessing the inside of the body requires an opening, an incision, a cut, a pathway through the surface. But now, imagine a being that can move through a fourth spatial direction. To that being, your body would not be a sealed structure. It would be something they could access directly, without crossing the surface in any way you can observe. They could reach into your body, not by breaking through, but by moving in a direction you cannot perceive. And from your perspective, something inside you might simply appear or disappear without any visible cause. There is no need to dwell on the discomfort of that idea. Instead, notice the structure beneath it. It follows the same pattern we've seen before. Each dimension defines what is accessible. Each new dimension expands what is possible. To a two-dimensional being, the inside of a closed shape is unreachable. To a three-dimensional being, it is trivial. To a four-dimensional being, and the same shift would happen again. What feels impossible at one level becomes simple at the next. There is a quiet elegance in that progression, because it suggests that complexity is often just a matter of perspective. What seems like a locked room is only locked within a certain set of directions. What seems like a sealed boundary is only sealed within a certain dimensional framework. And beyond that framework, the rules expand. Now, this doesn't mean that such higher dimensional interactions are happening around you in any direct or observable way. There is no need to imagine hidden beings moving through unseen directions. The value of this idea lies elsewhere. It helps you understand something deeper about reality. That the structure of the universe is not limited to what feels intuitive, that what you perceive as complete may be part of a larger system, and that the rules you observe are not broken. They are simply local. They apply within the dimensions you experience. But beyond those dimensions, the possibilities widen. There is something calming about seeing it this way, because it removes the sense of contradiction. The world remains consistent. The rules remain intact. They are simply part of a bigger picture. And as you sit with that thought, there is a gentle transition that begins to form. So far, we've explored the fourth dimension as something spatial, a new direction, a way of extending geometry beyond what we can see. But there is another perspective, one that does not treat the fourth dimension as an extra direction in space, but as something you are already moving through, something that shapes your experience of every moment, something that connects all events into a single, continuous structure, time. And as we begin to explore that idea, the fourth dimension becomes not just something beyond your perception, but something you are already part of. Up until now, we've been imagining the fourth dimension as something spatial, a new direction extending beyond the three you already know, a direction you cannot point toward, but one that follows naturally from the pattern of dimensions, and that idea, on its own, is already quite remarkable. But there's another way to look at the fourth dimension, a way that does not ask you to imagine a new direction in space, but instead invites you to look more closely at something you experience every moment. Time, not as something separate, not as a background ticking quietly behind the scenes, but as something woven directly into the structure of reality itself. This shift in perspective came into focus in the early 20th century, when a mathematician named Hermann Minkowski proposed a different way of understanding the universe. He suggested that space and time are not independent. They are part of a single unified structure, a kind of fabric, where every event is defined not only by where it happens, but also by when it happens. And in this view, time becomes the fourth dimension. At first, even Albert Einstein, who'd already developed the theory that motion affects time, was hesitant to adopt this perspective. It seemed overly abstract. too mathematical, too removed from physical experience. But gradually, something became clear. The equations describing motion, energy, and light were not just describing forces acting within space. They were describing the geometry of space and time together, a single structure. To understand this more gently, let's return to something simple. Imagine someone asks you a question. Where is your phone right now? You might answer by describing its position. It's on the table, near the edge, just within reach. That feels complete, but is it? Now imagine the same question, asked a little differently. Where is your phone, and when? Suddenly, something shifts. Because your phone is not always in that position. It was somewhere else earlier, it may be somewhere else later. Its location is tied to a moment. Without that moment, the answer is incomplete. And this is the key idea. In the deeper structure of reality, you cannot fully describe something using space alone. You need both space and time together. Every event, every movement, every interaction, every quiet moment is defined by 4 coordinates. Not in a mathematical sense that you need to calculate, but in a conceptual sense. 3 directions for space and 1 for time. There is a soft way to picture this. Imagine your life as a long thread, stretching through a vast fabric. Each point along that thread represents a moment, not just where you are, but when you are. From your perspective, you experience this thread 1 point at a time. You move from moment to moment, never seeing the full shape of your path. But from a higher perspective, the entire thread exists at once. A continuous line through space and time, and every object in the universe has its own thread. Every person, every particle, every star. Tracing out a path through this 4-dimensional fabric. This fabric is what we call spacetime. Not as a technical term, but as a simple idea. Space and time woven together. Now, there is something quietly beautiful about this view, because it changes how we think about motion. When you move through space, you're also moving through time. When you remain still, you're still moving through time. There is no escape from it. You're always travelling along your path through space-time. Even now, as you sit or lie still, your position is changing, not just in space, but in time. You're moving forward, gently, steadily, into the next moment, and the next, and the next. There is a kind of calm in recognizing that, because it suggests that time is not something that happens to you. It is something you move through, a direction just as real as forward or upward, but experienced differently. You cannot stop moving through it. You cannot turn back, but you are always, quietly, progressing along it. There is also something deeper here, because if time is a dimension, then it may not be flowing in the way it feels. Instead, it may simply be laid out as part of the structure of space-time, like a landscape, and your experience of time, the feeling of moments passing, may come from how you move through that landscape, not because time itself is moving, but because you are. There is no need to hold on to that idea too tightly. It can remain soft, like a thought drifting just beyond focus. What matters is the shift it introduces. The 4th dimension is no longer something distant or abstract. It is something you are already part of, something you are already moving through, without ever seeing it directly. And that makes it feel a little closer, a little more real. And as we continue to explore this idea, something even more surprising begins to emerge. Because if space and time are connected, then movement through one affects movement through the other. And that leads to a quiet, almost surprising conclusion, that the faster you move through space, the more gently your movement through time begins to change. If you sit quietly for a moment and simply notice your surroundings, there is a natural feeling that you're not moving. Your body is still. The room is steady. Nothing seems to shift or drift. It feels as though you're at rest, anchored in place. And yet, as we gently uncovered earlier, that sense of stillness is only part of the story. Because in the deeper structure of reality, you're always moving. Not just occasionally, not only when you walk or run or travel, but constantly, even now. You're moving through space-time. There is a soft way to understand this, one that doesn't require equations or complex descriptions, just a simple idea. Imagine that every object in the universe is always travelling at a kind of steady pace through the fabric of space-time. Not a speed you can measure with a number, not something you need to calculate, but a constant motion that never stops. Now here is where things become gently interesting. This motion can be divided. Part of it can go into movement through space, and part of it goes into movement through time. If you're sitting completely still, resting quietly, not moving from your position, then almost all of that motion is directed into time. You move steadily from one moment to the next. Seconds pass at a familiar pace. Your experience feels smooth and continuous. It's as if all of your movement is being used to travel forward through time. Now, imagine that you begin to move. Perhaps you stand up and walk across the room, or imagine travelling much faster, like an airplane crossing the sky or a spacecraft orbiting the Earth. As your motion through space increases, something subtle begins to shift. A small portion of that total motion is now directed into space, and because of that, slightly less of it is available for moving through time. The result is gentle, almost imperceptible. Time slows down for you, not in a dramatic way, not something you would feel directly. Your heartbeat remains steady. Your thoughts flow as usual. Everything feels normal from your perspective. But compared to someone who is moving more slowly through space, your journey through time is just a little bit slower. It's a delicate balance, almost like sharing a fixed amount of energy between two different paths. If more goes into one, slightly less goes into the other. There is a calm analogy that can help this settle in your mind. Imagine you're walking along a quiet path at dusk. You can walk straight forward, moving directly ahead, or you can angle your steps slightly to the side, moving both forward and sideways at the same time. Either way, your total pace remains steady. But how that motion is divided changes your direction. In a similar way, your movement through space-time is always present, but how it is divided between space and time can shift. When you're still in space, you move fully through time. When you begin to move through space, your motion through time adjusts ever so slightly. Now, in everyday life, these effects are incredibly small. So small that you would never notice them without precise instruments. But they are real. Astronauts, for example, who orbit the Earth at high speeds, experience this effect in measurable ways, because they are moving faster through space than people on the ground. Their movement through time is slightly reduced. They age, just a tiny bit more slowly. The difference is not enough to feel, not enough to change their daily experience, but enough to be observed, enough to confirm that time is not fixed and not the same for everyone. There is something quietly profound about that, because it means that time is not a universal flow that carries everything equally. It is something that depends on motion, on perspective, on how you move through the deeper structure of space-time, and yet despite this complexity, your experience remains smooth, continuous, unbroken. From your perspective, time always feels the same. There is no sudden slowing, no distortion, no sense of anything unusual, because you are always moving along your own path, at your own pace. There is a gentle comfort in that. You do not need to track these changes. You do not need to measure them. You simply move, quietly, steadily, from one moment to the next, and the universe adjusts around you. There is also something else hidden within this idea, something a little more subtle. If everyone is always moving through space-time, but in slightly different ways, then each person's experience of time is, in a sense, their own. Not completely separate, not disconnected, but not perfectly shared either. Two people moving differently through space may not experience time in exactly the same way. Even if the difference is small, even if it goes unnoticed, it is still there. A quiet variation, woven into the structure of reality, and this leads to a deeper realization that time is not something absolute. It is not the same everywhere, for everyone, at every moment. It is part of a relationship, a balance between movement through space and movement through time. And as you sit with that idea, letting it settle gently, there is a natural curiosity that begins to form. If motion through space can change how you move through time, then what happens when that motion becomes extreme? What happens when something moves incredibly fast, or exists in a place where the structure of space-time itself is different? How far can this shift go, and what would it mean for time itself to stretch, to slow, or even to nearly stop? There is a quiet assumption we carry with us every day, that time moves the same for everyone, that a second for you is a second for someone else. Whether they are nearby or far away, whether they are resting or travelling, it feels natural to believe that time is steady, shared and universal. But as we begin to look a little closer, that assumption starts to soften. Because time, it turns out, is not as rigid as it seems. It can stretch, it can shift, and under the right conditions, it can slow down. There is a gentle way to approach this idea. Imagine two identical clocks. Not ordinary clocks, but perfectly synchronized ones, ticking at the same steady pace. At the beginning, they are side by side, keeping time together moment by moment. Now imagine that one of these clocks begins to move, slowly at first, then faster, perhaps placed on a high-speed aircraft or carried aboard a spacecraft orbiting the Earth. The other clock remains still. From your everyday intuition, you might expect that both clocks would continue ticking in exactly the same way. After all, time is time, isn't it? But something subtle happens. The moving clock begins to fall behind, not because it is broken, not because it is malfunctioning, but because its motion through space has changed its motion through time. It is still ticking normally, from its own perspective, but compared to the stationary clock, it is moving through time more slowly. There is something quietly surprising about that, because it suggests that time is not something that flows independently of motion. It is connected to it, woven into it, and as motion changes, time changes with it. Now, the effect at everyday speeds is incredibly small. So small that you would never notice it without careful measurement, but scientists have measured it. Clocks placed on fast-moving aircraft compared to clocks on the ground show tiny differences. Satellites orbiting high above the Earth experience time slightly differently than we do here on the surface. These differences are not imagined, they are real, and they are consistent with the idea that time is part of the structure of space-time, not something separate from it. There is a soft way to visualize this, one that doesn't rely on numbers or equations. Imagine that your journey through space-time is like moving along a path. When you're at rest in space, your path moves straight forward through time. You progress steadily, moment by moment, without deviation. But when you begin to move through space, your path tilts slightly. Part of your motion shifts sideways, into space, and as a result, your forward motion through time becomes just a little slower. It's not that time itself is stopping, it's that your path through it has changed. There is a calm, almost poetic way to think about it, as if time is not a river carrying you forward, but a landscape you're walking through, and the direction you choose to walk changes how you experience that landscape. Now, if your movement through space is gentle, the change is barely noticeable. But if your speed increases, the effect becomes more pronounced. At extremely high speeds, approaching the speed at which light travels, the slowing of time becomes dramatic. From your perspective, everything would still feel normal. Your thoughts would flow at their usual pace. Your heartbeat would remain steady. You would not feel time slowing down. But to someone watching from afar, your clock would tick more slowly. Moments would stretch. Time, for you, would pass more gently compared to theirs. There's a famous thought experiment that captures this idea. Imagine two twins. One remains on Earth, living a quiet life. The other travels on a journey through space, moving at extremely high speed, then returning home. When they reunite, something unexpected has happened. The thus travelling twin is younger, not by a tiny fraction, but by a noticeable amount. From the traveller's perspective, their journey felt normal. Time moved as it always does. But compared to the twin who stayed behind, less time has passed. This is not a story or a metaphor. It is a real consequence of how motion affects time, and it has been confirmed in smaller ways through experiments and observations. There is something quietly profound about this, because it tells us that time is not fixed. It is not the same for everyone. It is something that depends on how you move, how you travel, how your path unfolds through space-time, and yet, despite all of this, your experience remains smooth, continuous. You never feel time speeding up or slowing down. You simply move through it at your own pace. There is a kind of comfort in that, because it means that even in a universe where time can stretch and shift, your experience remains steady. You're always centered in your own flow of moments. And as this idea settles gently in your mind, another question begins to form. If time can change depending on how you move, then what does it mean for two events to happen at the same time? Is now something universal? Or could it be that what feels like the same moment to one observer might not be the same moment for another? There is a quiet idea we carry with us, almost without noticing, that there is a single, shared now, a moment that stretches across the world, across cities, across oceans, even across the stars, a present that everyone, everywhere, experiences together. It feels natural. If you look at a clock, you assume that somewhere else, another clock is showing the same moment. If two events happen at the same time, you imagine them unfolding together, synchronized, aligned within a single universal frame. But as we continue gently exploring the nature of time, this idea begins to shift, because now is not as absolute as it seems. There is a soft way to approach this. Imagine a long train moving smoothly along a track at a very high speed. Inside the train, a passenger sits quietly, watching the world pass by. The motion feels steady, almost unnoticeable. Everything inside the train seems calm and normal. Now imagine that, at the exact same moment, two flashes of light occur, one at the front of the train and one at the back. From the perspective of someone standing outside on the ground watching the train pass by, these two flashes happen at the same time. The light from both ends travels toward the center and reaches the observer at the same moment. To them, the events are simultaneous. they happen together. But now, gently shift your perspective inside the train. The passenger is moving forward along with the train. When the flashes occur, the light from the front of the train has to travel backward to reach the passenger, while the light from the back has to travel forward, because the passenger is moving toward the front and away from the back. The light from the front takes slightly longer to reach them, and the light from the back arrives a little sooner. From their perspective, the two flashes did not happen at the same time. One happened before the other. Now neither observer is wrong. Each one is simply experiencing events from a different state of motion, and because of that, their sense of now is different. There is something quietly profound about this, because it tells us that simultaneity, the idea that two events happen at the same time, is not absolute. It depends on how you are moving. It depends on your path through space-time. There is a gentle way to sit with this idea. Imagine that every observer carries with them their own slice of reality, a way of dividing events into past, present, and future. For someone at rest, that slice might look one way. For someone moving quickly, it tilts slightly, shifting which events are considered now. The universe does not enforce a single shared present. Instead, each observer has their own, and these different nows are all equally valid. There is no preferred perspective, no universal clock that defines the present for everyone. Only relationships between motion, space, and time. At first, this idea can feel a little disorienting, because it gently challenges something very fundamental, the sense that the present moment is shared, that there is a single now connecting all experiences. But there is also something quietly beautiful about it, because it suggests that reality is not built around a single timeline. It is more like a woven structure, where different observers trace different paths, each with their own unfolding of moments. There is a calm analogy that can help. Imagine a vast landscape, stretching far in every direction. Two travelers walk across it, but along slightly different paths. From above, you can see both of their journeys at once, but each traveler experiences the landscape step by step, moment by moment, based on their own movement. Their experiences are not identical, but they are both real, and in a similar way. Each observer's experience of time is shaped by how they move through space-time. There is also a deeper implication hidden here. If now is not universal, then the distinction between past, present, and future may not be as fixed as it feels. What one observer considers to be in the present, another might consider to be in the past, or the future. Not because events are changing, but because the way they are divided into moments depends on perspective. This idea is sometimes described as a kind of block structure of reality, where all events, past, present, and future, exist within a larger framework. And what we experience as the flow of time is simply our movement through that structure. There is no need to hold on to that idea too tightly. It can remain soft, like a distant horizon. What matters is the shift it introduces. That time is not a single, shared thread. It is something more flexible, more dependent on motion, more deeply connected to the structure of space-time. And as you sit with that thought, letting it settle gently, there is a natural sense of quiet wonder that begins to form, because the world you experience this moment right now feels so immediate, so present, so real. And yet, it may not be the same now for everything else. Not for someone moving differently, not for something far away. Each perspective carries its own present, its own unfolding of time, and all of them coexist within the same universe. There is something peaceful in that realization, because it softens the idea of time. It becomes less like a rigid line, and more like a gentle, flowing structure, shaped by how you move within it. And as that idea rests quietly in your mind, another question begins to emerge. If motion can change how time flows, and perspective can change what counts as now, then what happens when space-time itself is no longer flat and even? What happens when it bends, when it curves, when it is shaped by something deeper? There is a quiet question that has followed humanity for a very long time. What is gravity? At first, the answer seemed simple. Objects fall because something pulls them downward. A force reaches out from the earth, drawing everything toward its center. Apples fall from trees. Rain drops from the sky. You feel your weight pressing gently into the ground beneath you. It feels natural to think of gravity as a kind of invisible pull, and for a long time that idea worked well enough, but as our understanding deepened, something began to shift, because there were small details that didn't quite fit the picture of a simple force. The motion of planets, the bending of light, the subtle ways objects moved in strong gravitational fields, all of it hinted at something more, something quieter, something more geometric, and eventually a new way of seeing gravity emerged, not as a force that pulls, but as a shape, a gentle bending of the very fabric of space-time itself. There is a soft way to imagine this. Picture a large flexible sheet, stretched out evenly in all directions, smooth, flat, undisturbed. Now place a heavy object at the center of that sheet, a ball perhaps. As it settles into place, the sheet begins to curve, not sharply, not abruptly, but gently, forming a smooth depression around the weight. Now imagine placing a smaller object on that sheet. Instead of moving in a straight line, it begins to follow the curve created by the heavier object. It rolls inward, not because something is pulling it directly, but because the surface itself is no longer flat. Its path has changed. This is a simple analogy, but it carries a deep idea. Gravity is not something reaching out and pulling objects. It is the result of space-time being curved. Mass, things like planets, stars, and even you, gently bend the structure of space-time around them, and other objects simply follow the shape of that curvature. There is something quietly elegant about this, because it means that objects are not being forced to move in curved paths. They are following the natural straightest path available to them, within a curved space, a bit like walking across a gently sloping hill. From your perspective, you're walking straight ahead, but from above, your path curves, shaped by the terrain beneath your feet. In the same way, planets orbit stars not because they are being pulled by an invisible force, but because they are moving through a curved space-time. They are following the natural flow of that curvature. There is also something else hidden within this idea. Gravity is not just about space, it involves time as well. Mass does not only bend the space around it, it also affects the flow of time. Near a massive object, time moves more slowly, not dramatically in everyday situations, but measurably. Clocks placed closer to the Earth tick just a tiny bit slower than those placed farther away. Satellites orbiting high above experience time slightly differently than we do on the surface. These differences are small, but real, and they remind us that space-time is not just a backdrop. It is active, responsive, shaped by the presence of mass and energy. There's a calm way to feel this idea. Imagine that space and time are not separate, but woven together into a single fabric. When something heavy rests on that fabric, it does not just press down in one direction. It reshapes the fabric itself, stretching it, curving it, gently altering the paths that everything else will follow. And those paths, those natural lines through space-time, are what objects move along. There's no need for a force in the traditional sense. The motion comes from the shape. Now, in everyday life, these curves are incredibly subtle. The Earth bends space-time, but only slightly. The Sun bends it more, and in most situations the effects are so gentle that they feel indistinguishable from the simple idea of gravity as a pull. But in stronger environments, the difference becomes more apparent. Light, for example, which normally travels in straight lines, can be bent as it passes near a massive object. Not because it is being pulled, but because the space it moves through is curved. It is following the shape of space-time. There is something quietly beautiful about that, because it suggests that the universe is not held together by invisible strings or forces reaching across space, but by the geometry of space-time itself, a structure that shapes how everything moves, how everything interacts, how everything exists. And as you sit with that idea, letting it settle gently, there is a natural sense of calm that comes with it. The world feels less like a collection of forces acting on objects, and more like a landscape, a vast curved landscape, where everything follows the paths laid out by its shape. And yet, this landscape is not still. It is not frozen in place. It can change, it can shift, it can ripple, just as the surface of water can carry waves. Moving outward from a disturbance, so too can space-time carry subtle ripples, travelling silently through the universe. And those ripples tell us something remarkable, that space-time is not just a passive stage. It is something alive with motion, something that can bend, and even gently tremble. For a long time, it was natural to imagine space as something still, a quiet stage, stretching endlessly in all directions where events simply take place. Objects move, stars drift, light travels, but the space itself remains unchanged, calm and unmoving. And yet, as our understanding deepened, something unexpected began to emerge. Space is not still, it is not rigid, it is not an unchanging backdrop. Instead, it behaves more like something soft, something flexible, something that can bend, stretch, and even ripple. There's a gentle way to feel this idea. Imagine a calm pond at dusk. The surface of the water is smooth, almost perfectly still. It reflects the sky like a mirror. Nothing disturbs it. Now imagine dropping a single pebble into that pond. At the point where the pebble touches the surface, a small disturbance forms, and from that point, ripples begin to spread outward. Soft waves, moving in expanding circles, carrying the disturbance across the surface. The water itself is not travelling across the pond. Instead, the pattern of motion, the ripple, moves through it. Now, gently bring that image back into the fabric of space-time. When massive objects move, especially when they move quickly or collide, they can create similar disturbances, not in water, but in space-time itself. Tiny ripples, travelling outward through the universe. These are what we call gravitational waves. But there is no need to hold on to the name. What matters is the idea that space itself can carry motion, that the structure of reality is not fixed, but dynamic. There is something quietly astonishing about this, because it means that when something dramatic happens, like two massive stars spiraling toward each other, or two dense objects merging in a distant part of the universe, the effect is not confined to that location. It spreads, not as matter, not as light, but as a subtle change in the shape of space-time itself, a ripple. And as that ripple travels, it gently stretches and compresses the space it passes through. Not enough for you to notice directly, not something you would feel in your body, but real, measurable. There is a soft way to picture this. Imagine two points floating in space. As a ripple passes between them, The distance between those points changes ever so slightly. They move apart, then closer together, then apart again. Not because they are travelling through space, but because the space between them is changing, stretching and relaxing, like a gentle breath. Now these changes are incredibly small, so small that detecting them requires extraordinary precision, but they have been observed, not directly, like seeing a wave in water, but through careful measurement, through noticing tiny changes in distance, smaller than anything you would normally imagine. And from those changes, we know that space-time itself can ripple. There is something deeply calming about that idea, because it transforms the universe from something static into something alive with motion. Not chaotic, not violent, but quietly dynamic, like a vast ocean where waves travel across unimaginable distances, carrying the echoes of distant events. There is also something poetic about it, because these ripples carry information. They are like whispers from far away, telling us that something happened, something powerful enough to disturb the fabric of space-time and send that disturbance outward, and yet by the time those ripples reach us, they are gentle, barely noticeable, soft traces of something that occurred long ago in a place we may never see. There is no need to imagine anything dramatic. You can simply picture it as a subtle trembling of reality, a quiet motion passing through the structure of existence. Now, if space can ripple, if it can bend and shift and carry waves, then it is no longer just a stage. It is part of the story. It responds, it evolves, it participates in the unfolding of the universe. And this brings us a little closer to understanding the deeper nature of the fourth dimension. Because space-time is not just a combination of space and time. It is a structure that can change, a structure that can be shaped by mass, by motion, by energy, and in some places those changes become extreme. There are regions where space-time bends so deeply, where its structure becomes so intense that the familiar rules begin to stretch, places where time itself slows dramatically, where distances behave in unfamiliar ways, where the fabric we've been gently imagining is no longer smooth and calm, but drawn inward, pulled into something far more concentrated. There is no need to rush toward that idea. It can remain soft, like a distant horizon. But as we move gently forward, we begin to approach those regions, places where the bending of space-time is no longer subtle, places where the ripples become something deeper, where the structure of reality itself begins to curve inward, more and more, until it reaches a point where our usual understanding begins to fade. There are places in the universe where the gentle bending of space-time becomes something far deeper, places where the soft curves we've been imagining begin to fold inward, where the quiet ripples we spoke of give way to something more intense, not chaotic, not violent in the way we might first imagine, but deeper, slower, heavier. These places are what we call black holes, but rather than thinking of them as mysterious objects, it may be more calming to think of them as regions where space-time itself has been bent to an extreme, so extreme that the paths within it begin to behave in unfamiliar ways. There is a soft way to approach this idea. Return once again to the image of a stretched fabric. Earlier we imagined placing a heavy object on that fabric, creating a gentle curve. Now, imagine something far more massive, something so dense that instead of creating a shallow dip, it pulls the fabric down into a deep, narrowing well. The deeper you go, the steeper the curve becomes. The paths that once flowed gently now begin to spiral inward. There is a point, not a physical surface you can touch, but a boundary of sorts, where the curvature becomes so strong that nothing can easily move outward again, not even light. This boundary is often described as the edge of a black hole. But you don't need to think of it as a sharp line. It is better imagined as a quiet threshold, a place where the nature of movement changes. Outside this region, paths through space-time can curve, but still allow objects to move freely in many directions. Inside, the structure itself begins to guide everything inward, not by pulling, but by shaping the paths available. There is something deeply subtle about that, because nothing is being grabbed or dragged in the traditional sense. Instead, the geometry of space-time has changed so much that all possible paths lead inward, like walking in a valley so steep that every direction you step gently guides you toward the center. Now, let's pause for a moment and focus on something even more delicate: time. As we've seen, time is woven into space-time. It is not separate from space, but part of the same structure. So when space-time bends, time is affected as well. Near a black hole, this effect becomes very noticeable. From the perspective of someone far away, watching an object approach this region, something unusual begins to happen. The object appears to slow down. Its movements become more gradual, more stretched. As it gets closer to the boundary, this slowing becomes more pronounced. Moments seem to take longer. Processes that would normally unfold quickly begin to stretch out. From a distance, it may even appear as though the object never quite reaches the edge, as if it lingers, suspended in time. There is a soft way to imagine this. Picture time as something flowing, like a gentle stream. In most places it moves at a steady pace, but near a black hole, it is as if that stream thickens, not stopping, but becoming slower, more viscous, like honey. Each moment stretches, taking longer to unfold. Now, from the perspective of the object itself, nothing feels unusual. Its own experience of time remains smooth. It continues moving forward, step by step, moment by moment. There's no sudden pause, no awareness of time slowing down. Because from within its own path, everything feels normal. This is another quiet reminder of something we've seen before. The time is not absolute. It depends on perspective, on position, on how space-time is shaped around you. There is something both mysterious and calming about this, because it suggests that even in the most extreme environments, reality remains consistent, not broken, not chaotic, just different, shaped by deeper geometry. Now, as we move closer to the center of this region, the curvature becomes even stronger. Distances behave in unfamiliar ways. Paths that once seemed separate begin to converge, and the structure of space-time becomes increasingly difficult to describe using everyday intuition. There is no need to follow that path all the way inward. We can remain at the edge, where the ideas are still gentle enough to hold. What matters is the feeling this creates, a sense that reality is not flat and uniform, but capable of deep variation, that the fabric of space-time can stretch, bend, ripple, and in certain places, curve inward so profoundly that it reshapes the very nature of time and space. There is something quietly humbling in that, because it reminds us that the universe is far richer than what we experience in our immediate surroundings, that the rules we're familiar with are part of a larger system, a system that reveals new behaviors under different conditions, and yet, even in these extreme regions, there is a kind of continuity. The same principles apply, the same structure persists, only the scale and the intensity have changed, and as you sit with that thought, letting it settle gently, there is a natural sense of calm that follows, because the universe, in all its complexity, remains coherent even at its edges, even where time stretches and space curves deeply inward. And from that edge, there is a quiet step back, a return, from the most extreme expressions of space-time into the broader question we began with: what is reality truly, and how much of it lies beyond what we are able to perceive? And now, very gently, we come back, not abruptly, not with a sharp conclusion, but with a soft return from the deeper layers of space-time back to something simple: your breath, the quiet room around you, the familiar feeling of being here, in this moment. Throughout this journey, we've taken small steps, one after another, into ideas that stretch just beyond what we can easily see. We began with a simple thought, that you are never truly still, that even in the quietest moments, you are moving, gently, steadily, through time. And from there, something began to unfold. We saw how our understanding of reality is not the reality itself, but a kind of map, a simplified version, shaped by what our minds can perceive and what our bodies need to survive. We noticed how that map, while useful, leaves things out, how entire layers of existence, light beyond what we can see, sounds beyond what we can hear, patterns beyond what we can sense, quietly exist around us, unnoticed. And from there, we began to ask a simple question. If there are things we cannot perceive, could there be directions we cannot see? Could there be dimensions not far away, but woven quietly into reality itself? We explored what a dimension really is, not as a complicated idea, but as something simple, a direction, a way to move. We built that idea slowly, from a point to a line, to a square, to a cube, and then, just beyond what we could visualize, we reached towards something more, a fourth dimension. Not something mystical, not something separate, but simply the next step in a pattern, a direction that exists, even if we cannot turn toward it. We stepped into the quiet world of Flatland, where a simple square could not see up, and where a sphere passing through that world appeared as something impossible, a shape that appeared, changed, and vanished. And in that story, we saw a reflection of ourselves, because just as the square could not perceive the third dimension, we may not be able to perceive the fourth. We may only see slices, shadows, cross-sections of something larger. We imagined what it might be like if something from that higher dimension passed through our world, how it might appear, change, and disappear, not because it is breaking the rules, but because we are only seeing part of the structure. We explored the idea that what we experience as reality may be a projection, not false, not unreal, but incomplete. And then something even more surprising emerged. The fourth dimension is not only something we imagine in space, it is something we're already part of. Time, not as something that flows, but as something we move through, a dimension just as real as any direction in space, but experienced differently. We saw how space and time are woven together, forming a single structure, a fabric, and how everything, every object, every moment exists within that fabric. We noticed how movement through space gently changes how we move through time, how time can stretch, slow, and shift depending on motion, how even the idea of now is not shared equally, but depends on perspective. And then we went further. We saw how this fabric of space-time is not flat, but can bend, how mass gently curves it, shaping the paths that objects follow, how gravity is not a force pulling things together, but a reflection of that curvature, we watched as that fabric, so calm and smooth, revealed its ability to ripple, to carry subtle waves across vast distances, tiny echoes of distant events travelling quietly through the universe. And finally, we approached the edges, places where the curvature becomes deep, where time slows, where the familiar structure of space and time begins to stretch beyond what we can easily imagine. Black holes, not as objects, but as regions where space-time folds inward, shaping everything around them. And yet, through all of this, something remained constant. The universe did not become chaotic. It did not break. It did not lose its structure. It simply became deeper, more layered, more intricate than what we first perceived. And perhaps that is the quiet truth that rests beneath everything we've explored. That reality is not limited to what we can see, not confined to what we can easily understand, but something far richer, extending gently beyond the edges of our perception. There is no need to fully grasp it. No need to hold every idea clearly in your mind. You can let it soften, let it drift, like a thought that slowly fades as you begin to relax, because the goal was never to solve the mystery completely, only to feel it, to sense, just for a moment, that there is more structure, more depth, more quiet beauty, woven into the fabric of existence. And as your thoughts begin to slow and your body settles more deeply into rest, you can let that feeling remain, not as something that needs to be understood, but as something that gently expands the space of your imagination. A reminder that even in the stillness of this moment, you are part of something vast, something continuous, something quietly unfolding beyond what you can see. And in that awareness, there is a kind of peace, a softness, a sense that the world does not need to be fully understood to be deeply meaningful. So, as you drift a little further between waking and dreaming, let the ideas fade one by one until all that remains is the quiet, the stillness, and the gentle sense of being carried forward through time.